Hello everyone. In this video, we are going to see all about time travel feature in Snowflake. Snowflake's continuous data protection feature safeguards data against accidental or malicious action. These features enable data recovery from various scenarios like human errors or software failures by providing access to the historical data version. The two main features of CDP are time travel and failsafe. This video is focused on time travel feature in Snowflake. Now let's talk about time travel, one of Snowflake's powerful data recovery features. Time travel allows you to access historical data from table or database, even if it has been accidentally deleted, modified or dropped. Time travel supports querying the data as of specific timestamp or version. Time travel is very useful for data auditing, backup and version comparison. The default retention period is 1 day, but it can be extended up to 90 days on Enterprise Edition. Time travel works with SQL clauses like at, before or version between. Time travel makes data recovery in Snowflake simple, precise and efficient. It is a must-know feature for every data engineer and analyst working with Snowflake. Now let's understand how time travel works behind the scenes in Snowflake. Snowflake stores the data in micropartition, which are smaller chunks of data within a table. Every micropartition consists of a subset of the table's data. These micropartitions are automatically managed by Snowflake. So every time a data is inserted, updated or deleted, Snowflake doesn't overwrite the data. Instead, it creates new micropartition to store the changed data. This keeps the record of how the data is stored at every point in time. Let's take an example of this table in this diagram. For this table, Snowflake created 4 micropartitions. After this, we are running an alter statement. After the alter statement, Snowflake created 4 new micropartitions instead of modifying the existing micropartition. In short, time travel works because Snowflake keeps the timeline of micropartition. So when you use time travel, you are querying the historical version of micropartition and not rewriting or recovering from backups. Now let's see the practical implementation of Snowflake's time travel feature. For this demo, I am going to create a table test orders which has 2 columns, ID and status. Let me create this table. The table is successfully created. Let me note down the time in which the table is created. The table is created at 22:54. Let me note down the timing. Now let me insert one record which has the value 1 and the status as pending. Let me run this query. One record got inserted. Now let me note down the timing of insert. The record got inserted at 22:55. Let me note down. It is 22:55. I inserted the record. Now let me pause this video for some time and then I will do the update. Let me update the status as shipped. The status is now updated from pending to shipped. Now let me see the timing. I made the update at 22:58. Let me note down that. Now let's run the select statement. The status is now changed to shipped. Now I am going to run this query. Before 3 minutes, we see that the status is pending. We are querying the older data with the before keyword and with the offset -60 times 3. That is before 3 minutes. Now I am going to insert another record. The next record has the ID 2 and the value as cancelled. Now let me run the query. We have two records, one record with the status shipped and the other record with the status cancelled. Now let me delete the second record. The timestamp is 6:21 at 23:03. Now let me select this table. We have only one record with the status as shipped, and we have deleted the record which has the status as cancelled. Now let me do the time travel before the delete. At 22:56, the status was pending. We inserted the status as pending during 22:55. So when I selected the table at 22:55, I am seeing the status as pending. At 22:59, the status changed to shipped. O2, let me check. At 23:02, we see that there are two records. Now I am going to restore the deleted records. So I am going to insert the records into test orders table where timestamp is 23:02 and the ID is 2. Now let me insert this record. I am inserting the deleted record. We restored the deleted data. Now let's compare the before and after. At 23:01, we had the status as shipped, whereas in the current state, we have both the status. In the next scenario, we are going to create a backup clone from the earlier state. So I'm going to provide this timestamp. I'm going to create a table which is test order backup, and I am going to clone from the test orders table at timestamp 23:01. Let me run this. The table is successfully created. Now let me select this table. We cloned this table from the test orders table at the timestamp 2025-6/21 at 23:01. Now let's drop the test orders table. The table is successfully dropped. Now let me select the test orders table. We don't have this table currently. I'm going to restore this table using undrop table name. Let me restore this table. The table is successfully restored. Now let me select this table. The table was successfully restored and the data is also preserved. I hope you got a fair idea of time travel in Snowflake, and I'm sure that you learned something new today. If you do like this video, please consider to subscribe, and I will see you in another interesting video. Thank you.